Okay, in this episode of Washing Machine Series, it's episode 9. In the previous episode, I separated the inner and outer drums, and I've done many episodes before. So in this episode, I'm just going to take apart further components off of our old washing machine. It's our old Beko washing machine. So if you look back at the other episodes in my washing machine series, you will get the previous footage up to this point, basically. What started out as a Beko washing machine, top loader, I, in my previous episodes, recorded this washing machine's, our washing machine's final wash, and I've subsequently recorded the footage of me getting it disassembled to this point. On the previous episode, I separated the inner and outer drums, and I've got a bag of components that I took off. Nearly dropped the phone. Yeah, so this has all been taken off previously, off that model. This is the model. No, it did have the door brake on it, the powder dispenser. So originally, that's what it would have looked like, the control panel. So as I say, look back in the previous episode, you'll get the footage of it getting to this point. So I think on this episode I'm going to show what's inside the components. I don't know, I might take the main motherboard circuit board apart, well, control board, which is all here. This is what controls everything. There is another circuit board on this machine as well, the Triac. I think it's AC to DC. That was originally mounted. Well, here the old wiring diagram, the old wiring harness is still in the chassis of the machine, but all the components are out. There's not really much left to take out. That's just the mains capacitor, the mains input is where the flex goes into there, and then your wiring harness, which is really all that's left, and the hose, the outlet hose as well, which is still there, and they've got heat insulation. They've got the lower shock absorber struts that are still there. The corresponding ones are on the drum, as I explained earlier in my previous episode and previous episodes. So there's not really much left as regarding the machine as an assembly. That's where the inlet water came in. All the front panels removed, and the control board as well. I think in this episode I'm going to take apart the control board. So this is the main brains of the wash machine. In this bag there's just other components that I took off previously in the episode that I'm not going to cover in this one. It'll just make the video too long. I'm just going to cherry pick some of the components out there to take apart further. I took apart them in their sub-assembled form, and I'm going to break them down into the componentary form. So I'm going to now take off the circuit board off of the main control panel and see what's on the other side. And to do that, I think I would need to pry back these plastic clips. I don't see that there's any screws or anything in there, unless I took them out already, though I doubt it. I don't remember doing that, so I think it's just a case of prying back the plastic to get the the black plastic out from under the lugs, and then this whole circuit board should just come out. I might use a screwdriver. Because this machine's finished, it's not going back together again. It doesn't matter too much if they're broken, if I break the plastic lugs. Just using the flat screwdriver to pry these plastic bits out from under the white lugs. Now it's not easy to film this at the same time, so I'm going to have to put the camera down for this part. Now we unhooked the main circuit board, and from there is the switch panel, which is really all they do is these press like the pegs at the back. So when you press the switch, right, I don't know if I could show you this, but I'll try. So I'm pressing the switch, right, and you can see the peg moving. I think it's made of acrylic, and they meet up with the switches on here on the circuit board. the pro plate switches, so you could kind of like maybe, well, that'll be the dial. You can kind of see where they match up. That's the speed control, so that other check. You can see when I turn this, trying to show you, on one, I haven't got a camera stand, so I'm doing my best to show you this. I'm turning the dial at the front, which you can see what's happening there. That there corresponds with this. So when you're turning the dial, this will turn the switch in accordance. I don't know what that's doing at the back. I think it's setting as blue. You might see that movement there actually. Black. If you look at that black bit there, and then turning this, now it's not easy to do to demonstrate, but I'm trying my best. You might see the black thing moving. That's the switch. That must be for the program that sets the program. And the other buttons here, that's the display. That corresponds with that. These buttons will correspond with these. So you press these at the front, which makes these bit, which pushes the pegs there. And I'll try my best to show you this. It's not so easy, but you might be able to see. You might see that one moving, and then pressing that. And that's just all it's doing is pressing against there, which will set the temperature, spin speed, etc, etc. The time delay, that's the time delay one there. That corresponds with that. The start and stop will be that one there. Set apart, you've got like 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So that is that. That will correspond with that, and you get the idea. That end up with that one matching up with that. Display. The display was just acrylic. You stay there, you see it through there. So, I don't really know what they could do with this. There's not really much to show. I mean, it's all encased in plastic shrouding, so I don't really think there's an awful lot. There's a capacitor down there as well. We can maybe try and highlight that for you. There's not really much point in breaking into this, because you could see all there is really. You've got the relays. I think they're relays. These are the connectors for the wiring harness. So the wiring harness connected up to them. That's the connectors on the wiring harness, the corresponding. They just push fit onto the circuit board, just push fit onto these, that's how they're connected up. So I don't really see the point in breaking this, because there's nothing really more to see. I don't know if this might come off actually. I might be able to get this just by prying off the tabs, as you could see what I'm doing. I could maybe remove this cover, put the camera down for this point, remove this black cover, and this is the dial, the peg. All that did is that went through there, that hole there, that connects up to this. So when you're turning this, it turns that through that hole and it ultimately into the circuit board here. So this is what it's doing. You might hear that and see that. And that's for that there, that's what that turns against. Microprocessors there. I'll see if we could amplify that picture for you. So what's that? The next thing I could break into is the soap dispenser. I don't think there's an awful lot, but I'm going to see what is in there. Like, the water channels at the top. First of all, to remove the drawer, just press down on that and pull it forward. Now, because I'm holding the camera in this hand, I'm going to have to put this down. So when you're pressing down on this to remove the dispenser drawer, the soap dispenser drawer, all they're doing is pushing down on that plastic there, which releases it from a tab in there, basically. Now, it's not very clean, but that's just through years and years of usage. So what puzzled me is how the water actually got into the centre to wash the softener into the drum. I know that the channels on the top here, water comes in from there and it will go into the pre-wash, and for the main wash the water will come in through the hose, wash the main wash powder in there. But to get the soap, the softener rather, what I reckon is that they put both water jets on, well, both valves opened and you had water coming in there, water coming in there, which kind of, when they met, they crashed into, the water would collide and then eventually, you know, it would escape along here. So it's going to force water along this centre channel to wash the softener in. That's what I reckon. But to see, I don't think there's any valves or anything in there, but it's going to settle my curiosity if I somehow manage to break into there to see if there is anything. I really don't think there is, but I'm going to do it anyway. I can't really see why there would be or how there could be. There doesn't seem to be any evidence of that. I think it's just a case of the water would come in there and there at the same time in order to flush the softener down. But I'm going to get a hammer and break into there anyway, and just to see if it'll satisfy me that way. I've got my hammer. I think all I would need to do is to put this on the ground and just batter it with the hammer to break it, and then once I knock a hole in it, then I could see inside. So I'll put this down. I won't be able to film that, but I'll show you what the results are. After a few hits with the hammer, I managed to break into it, and it reveals exactly what I thought. Nothing. Now, I took great care. I had gloves on. I closed my eyes so no fragments of plastic, you know, goes in my eyes. Although that if it was strong enough, the plastic would just penetrate through your eyelids. So really, goggles would be best for that. But just being extra careful anyway. So anyway, that's what's inside. There's nothing. So that's the three channels there. The water. There's nothing there to divert the water in any way. It's just a simple case as it would follow the clear cut channels. There's no valves or anything. That's the softener one in the centre. There's nothing there to like any valves or flaps. So the water must come in, and as the, you know, to get the centre flow for the softener. Now that is absolutely filthy, by the way. Not very nice. Something I didn't bank on, but never mind. Hands filthy. The water would come in for the pre-wash, which is that one. Wash the pre-wash powder in. The main wash, which is through there. And you'll see earlier the way the hoses were diagrammed. Well, you'll see earlier the way the hoses were connected up on earlier episodes. But for the main wash, it'll go through there, along this channel, wash the powder in. Now for the softener, the two of them, the only way to get this softener in for the softener is that the water would come in from there and there. The water would then collide with each other and create a jet of water that would come through the centre to wash the softener down. That's kind of what I suspected at the time when it was working, when this machine was working, because I couldn't figure out how. There was only like two hoses connected to it, you know, and I thought, well, where's the third one for this? But just as a thought, it's a simple water colliding with each other, and it will go through the centre one. So that's that mystery solved. It was brutal to break into it, but as I say, this machine's finished, it's scrapped, and I'm just learning from my own curiosity and then sharing it with you. So that satisfied me to know for certain that there's no any mechanisms. There wasn't any evidence of any pivots or mouldings for pivots to allow any flaps to operate during that to get the softener water in. It's just a simple case that two jets would collide and then it would form into a centre, you know, cause the water to go through that centre channel, water channel. Right, so there's not really much in the way of a powder dispenser. There's not much in there. It's fairly self-explanatory. Another thing I could do, I could take this heat shield off this triarc circuit That I think's the big heat shield for the triac in there. It's got the 3 legs on it. It's like, well, it's actually got the 4 legs on it. It's something like a transistor, but it's are 2 rectifiers together. My dad's an electrical engineer, he'd be able to explain what's better than me, but I'm just giving you my knowledge. And all I say in these videos are only for entertainment purposes only, and don't quote me on what I'm saying. It's only for entertainment, so I'll try and remember to say that on all these episodes. I'm going to take off this Phillips screw to reveal what's in there. This circuit board was situated there on the washing machine, and it would have been connected up with one of these wire harnesses, a couple of connectors going to it, if I remember right. I've got a Phillips screwdriver, and I'm going to simply unscrew this Phillips screw. When I said I would simply remove this Phillips screw, it's not so simple. The screw's turning, but the problem is the nut on the other end is turning with it, which is a problem. I think what I'm going to use is a pair of needle nose pliers to hold that nut steady, at the same time unscrew that screw, so that the whole thing's not spinning around like what it's doing, because it ain't going to come off like that. So I'm going to have to get needle nose pliers into there. That's what I'm going to use anyway. I'm going to use needle nose pliers. I know a mechanic, I'm not a mechanic, an electrician. I just do what I need to do to get this off. As I say, this is really for entertainment purposes only. There is procedures and stuff to do it, but I've been distracted there. I looked at the circuit board, and at the same time as I'm thinking of that, and just says to myself, I wonder if I could get the circuit board out of this plastic shell, because I'm just looking at these tabs. See them? So they just tab back, and that will allow this whole circuit board to come out. So I've just been sort of like sidetracked a little bit there. What I'm going to do, because I was sidetracked, and I'm going to break the order that I'm doing it, and I'm going to stick with the order. I'm going to deal with this. Once I've dealt with this, then I'll come back to this circuit board, and I'll remove the circuit board from the plastic shroud, because up on, just as I looked there, as I was sidetracked to the saw, they're just held in with plastic lugs, the same as the whole thing. So I can remove the circuit board out of this afterwards. But I'm going to stick to the original order. I'm going to, that by the way is just damping, because this goes against the side of the machine, that's just acting as a kind of just a soft, so it kind of takes away any vibrations, like a sponge absorber. Just because this is going against the sidewall, the metal sidewall of the washing machine, and that just acts as a kind of a buffer, if you like, because of all the vibrations that go on in the washing machine. But anyway, back to the original task at hand here at the moment. I'm going to get needle nose pliers, hold the bottom screw nut, and take that screw. Pliers, I'm just going to use these to go into that, hold that nut. That's able to slacken it off quite well. First hand, what's going on? I just literally got it slackened. I'll remove the screw and show me removing it as I speak. Although I think actually I'm going to need to hold on to that nut, unfortunately, so I'll just have to do that. 2 hands to do that. Now I've got that screw up, it's quite long. That's the heat shield I'm moving, that's the nut and washer, serrated washer, which is on the other side. Now the heat shield seems to be tabbed onto the circuit board. Now I'll try and show you what I mean. I think I'm going to have to get the pliers into there to bend that, bend that metal tab, which will release this from the circuit board. So I need to bend these, because there's one at each corner, there's one there as well, and there'll be one on the other side, which doesn't look so easy to get to. Yeah. So I'm gonna have to twist them to get this off. Quite awkward to get them in there, so I'm going to remove this back plastic bit. This plastic bit here, I'm just going to remove it. That's held on with these tabs at each corner, so I'm just going to pull back these tabs to release the circuit board. Better still, there's this main tab at the front. That seems to be that if I remove that from the circuit board, then the circuit board slides out from the top ones. So I've got to move this big one at the bottom, got to pull that back to allow the circuit board to slide out from under there, so the whole board comes out like that. Oh, it's just a little bit of persuasion, but that's what was going on. The circuit board slides. There's a couple of pegs and dowels there as well, but they just locate into the circuit board there and there. That kind of helps locate it, because it's got to be firmly fixed, because there's a lot of vibration going on in the washing machine. So and as I say, the thing was just sliding in, like the bottom bits of the circuit board. That edge was just sitting in there and in there as well, so that was, you can see where it goes. The top one, this is the release, so I was just pry back on that, and that allowed the circuit board to come out from it, to unlip from it, so I was able to pull it off with this plastic back plate. Now that means I can now get access to these, because I need to twist those in order to get this heat shield off. Those twisted, I can now lift the circuit board away from the heat shield. It's got heat proof paste as well, that white stuff that's on there. This does get very hot, as you can see. Now, there's a lot of voltages that go in here, that's why it's darkened. I think that the voltage, high voltage stuff, attracts a lot of dirt because of the static forcing. I think it causes static electricity as a byproduct or something, I'm not sure, but there's certainly the higher voltage stuff seems to be darker than the lower voltage stuff. You can see in contrast, that's low voltage microprocessors, milliamps, and this is high voltage, high current, and you can see it's a lot more darkened, carboned. It's even got it written on it as well. So that's your mains voltage that is going in there. I think this converts it to DC or something. I don't know what's in here, but I'm not going to bother breaking into that. It's quite solid, whatever it is. So, and this is, again, it's just a closer look at it anyway. So the electrical engineers will know what this is. My dad will know exactly what it is, but he probably told me at some point. I can't remember everything, but I'm interested. I am interested to learn. I'm trying to get the writing that's on there. It keeps going out of focus. Ah, there we go. Much better. So, it could be AC to DC or something. Triac, I think it is. But it does get hot. This aluminium heat shield kind of proves that you've got heat paste. This is just, I think it's something to do with the motor. Distributes power to the motor. This certain winding, there's 3 windings that are out of phase, I think. Phase 1, 2 and 3. But anyway, I'm not a washing machine repairman. I couldn't really explain everything like the way they do. I've just got a very rough understanding. As I said, don't quote me on it. I'm just showing you this for entertainment purposes only. Now, going back to what I was going to, I'm going to remove the circuit board from here, because it's held onto the plastic things. I don't need very many tools to get this taken apart. There seems to be a lot of these plastic lock tabs, which is quick for assembly purposes, I guess. When they make the washing machine in the factory, I think it's easier for them just to use these click methods. Not ideal, because through time, if it has to come off, these could break. But if it was screwed in, you know, it would take more time to build. But at least when you screw it and unscrew it, there's not a risk of breaking plastic tabs. Like, these are just more like, I think, more like one-time use, because they've got a tendency to break. And through age as well. It's quite an old machine, so the plastic will probably get brittle. Right, so I've pried the circuit board off of this plastic back plate, or back shrouding to protect it. This is the bare circuit board. And now that that's plastic's off, you can see more of the rear side of the circuit board, where all the heavy current relays are. At this right hand side of it, that's where all the motor controls are as well, I believe, because you can see it's kind of darkened, which means it heats up, and it's probably dealing with high current, high voltage, and tends to maybe attract dirt because of static reasons. So slightly on the lower side of the, well, it's 240 volts anyway. So, but this is where the brains are, the microprocessor's the brain. That's the electronics use low current, low voltage, whereas the electrical, the muscle of the washing machine, is uses the high current, high voltage, and it seems to be there's higher voltage at this side. It seems to be the heavier components. It's like an inducer or something. A small inducer, like a transformer, a mini transformer for altering the voltages and stuff. There's a wee heat shield here as well, and there's an interesting sort of circuit board. Transistor or something down there. Ah, I think I know what that is. That's a thermal cuttle. That's bimetallic strip. Just having a look at a closer look at that with the light on it. That there, right? I think that must flex through heat, through temperature. That you might see. It seems to go out of focus a little bit, but that I think must have something to do with that'll warp, that'll bend its shape due to temperature, which will trigger a switch. This is a heat shield, so it's dealing with heat. Now on the other side, I don't know if I could show you this. I'll study this circuit board. I'll try and zoom in with the camera. That'll help. Right, so I'm zooming in now to the best I could. It seems to go out of focus an awful lot, but it's nothing I can do about that. So I'm sorry. But I think that's a switch. That must trigger a sort of switch. You can maybe see it down there. Oh, this is hopeless. There you go. No, you can maybe just see it down there. So I think that just moves due to thermal expansion or contraction, either or, and as a result it'll make or break a switch. So it'll break the circuit if it overheats. So if the motor starts to overheat, then this will get hot because it'll be drawn current through this transistor, MOSFET transistor, I think it's called. So when it's drawing all this current, if it starts to get too hot, then this bimetallic strip, I think that's what it is, will act like a thermostat, and it'll cut the power so it doesn't burn at the motor, basically. Because if it burns at the motor, then your motor's going to be absolutely knackered. It might even go on fire, and that'll be a disaster. So they've got to have a safety switch built in. So when things get too hot regarding the motor, this will heat up. It'll expand, it must trigger some sort of, I don't know for sure, but I think it'll trigger a switch. It'll break the circuit, which will cut the power at the motor. Until the motor cools down, well, until this cools down, then it will trip back on again. That's my understanding. Don't quote me, as I say, I'm just guessing, but looking at that, it's dealing with heat, because you've got heat paste there in the back of this transistor, you've got a heat shield, and there's like a bimetallic strip. So I can't be bothered breaking it off, but I don't think there's a lot to see anyway. You can see what's there, and I reckon somehow it must cause a, you can maybe see the corresponding contact on the plate. So if it makes contact, that might start to expand as it gets hot and cause us to make contact with that. I'm just guessing, by the way, and in doing so it will either close the circuit to trigger a relay to break the circuit. I don't know. I reckon it's a thermal switch anyway, that's my guess. I say, I'm not a washing machine repairman or anything like that, I'm just guessing. It looks, well, that's what it looks to me. It looks interesting anyway, I'd like to learn more, but maybe you could put some stuff in the comments if you know, and if you want to say what you reckon it is. Then just bang them in the comments at the bottom. Let us get. What else? Right, let's have a look in this black bin liner full of the components and see what else I want to take apart. Okay, what have we got here then? Right, so this is the inlet solenoid. The water comes in through this wee gauze here. That kind of acts as a screen or a filter. Like I was saying earlier, that's the two hoses that hook up to what was once the washer dispenser. Simply a solenoid. I don't think there's an awful lot can't really break into that, so there's not really much to see. There's no much point in breaking it with a hammer. There's a coil and a magnet. Let's see what else there is. Yeah, this is the pressure switch. I will be interested in seeing inside this because I think there's a diaphragm in there that must be affected by the pressure. This connects to the bottom of the drum. So when the drum fills up with water, it must affect the pressure in this hose, which will in turn perhaps cause a diaphragm to move, a diaphragm in there which will move, and then on the diaphragm there'll be maybe like contacts that will make or break a circuit. So when it's time to, once the water's reached a set level, calibrated by this device, then that'll cause the diaphragm to move inside there, and it'll basically tell the brain, will send a signal via the wires to the main brain here, microprocessor, which will tell these solenoids to shut down. Basically it'll cut the power to them, and then that will stop water coming in. So I want to break into here and see this, what I think. I'm guessing there's a diaphragm in there anyway. Into it, I think it's non-serviceable. There is little tabs along the circumference. I'll see if I can maybe try pry and open that first. See what I can do on that one. I managed to pry it open with a flat screwdriver. I tried the weighing first, but that was not really working, so I used a bigger flat screwdriver. I needed a little bit more force. I managed to get this separated. This is just where the hose connects to the housing. Now I believe this is the diaphragm that will be affected with the water, with the pressure, because the air pressure in there, as the water fills up in the drum, this is connected to the bottom of the washing machine outer drum. So in the drum, which is here, there's a wee like nipple on this casing somewhere, where that, I don't know where it is in there, but I did show it on an earlier episode, so if you want to look back on, I can't remember what one it was, but this is episode 9, so it'll be any one before this one. This connects to the outer drum, so as the drum fills up with the water, like I explained earlier, it goes through the water system, fills up, and this, as the water fills up in the drum, the inner drum, where the clothes are to get washed, the air inside this rubber hose will become affected. It will start to, I would think, it would start to pressurise it, and as in doing so, it will cause, from through this small hole there, this is the other side of this block, that pressure will cause this diaphragm to move ever so slightly. Now under this diaphragm, first time I took it off, it's just a rubber diaphragm, very light sensitive, which will cause, because it's a surface area, the pressure will be not amplified, but it will be utilised more because it's got a bigger surface area to act on, which will cause a very small movement within this. I think it's magnetic. No, it's not magnet. There's a spring in there as well. But I'm certainly going to guess that as the pressure increases, it's going to push that diaphragm, which is going to push this white disc against this spring, because this spring must be there to put it back in the reset position. That spring's fell out, so I'll put a light on in there, shine it in there, and I'm guessing the micro switch will be in there because the contacts are there for the electrical. So I reckon anyway that this plunger or whatever the heck it's called will cause something in there to push up against the switch, which will basically send a signal. It'll complete the circuit, so once it does that, it'll send a signal to the brain here, the microprocessor, which will tell the water to shut down, just to switch off, it'll cut the power to the solenoid, and the spring will close the valve and shut the water off from coming in. So the water will only come up to there, it won't go through the hoses and fill the drum up anymore. And that's my understanding of how the pressure switch works inside our old Beko washing machine. So that's pretty much that as far as I'm concerned anyway. What else is in here now? Door lock. The door interlock, is it? Right, so this is the door lock. That is responsible for making sure that the door in the washing machine doesn't open when it's in use. Right, that's fine. Hang on. Okay, where was it? The door lock. Basically, it's a door lock for the washing machine front door, the front loader washing machine. And when there's no power to it, basically you can open the door, but you're just opening the door. So this, when you put the power on, once the machine starts its wash cycle, this will energise and it will make sure that you can't open the door. It'll lock the door shut. So you try and pull it, it'll not open, because this is a safety measure, and it's for kids and that. Because the water in the machines could go up to 90 degrees centigrade, which is pretty close to boiling hot water. So it doesn't bear thinking about what could happen. And the spin on that could go up to, the motors are nearly a horsepower. So you just imagine what would happen if you accidentally open the door while it's in use. So that has got to be there. It's just to make certain that that door will not open when the machine's in use. So what I'm going to do is I'm not quite sure how it works. I don't know what's inside there, but I reckon it's going to be like a solenoid basis, electromagnet or something, cause the locking system. But I'm going to know for sure because I'm going to break into it somehow and see what's inside it, and then see what I can learn from that. For inspection, I think what I need to do is pull back on these tabs. I think this is non-serviceable, so meaning it's sealed for life. So the only way to get in is to break in, which means these tabs could probably just break right off. So I'll try doing it, without breaking them, see if I could separate this white cover and I could have a look inside. What I've done is I just basically had to break the white cover off, because these plastic things, as I say, it's sealed for life. Once it's broken, that's it, it's buggered. It will never go back together again. So I think if they ever do break, then you want to keep your washing machine, then you wait to basically just buy a new one. You'll have to replace the whole unit. I don't think, because just slightly, even gently moving these tabs back, they just snapped off. And that's the whole thing buggered. So if this fails on your washing machine, I think you just have to simply buy a new one and fit a new one, rather than take this off and try and open it up and repair it. Because these plastic things, certainly on this model, they're very, very flimsy, and I think it's sealed for life. Once it's on, it's not to come off. Now, inside here, I reckon this must get energised and cause this tab maybe to... No, I'm just not quite sure what's going on here. I might have to just pull this right back and see what's going on. This plastic bit seems to be... what I might actually do is I'm going to get... No, can't I? No, well, I'm going to get the front panel with the door still on and just see how this fits on to the door on the washing. The front panel of the washing machine, which includes the door. Now, like I say, you'll see this machine working on its very last wash. If you look back on the episodes, it's titled accordingly. The door lock. No, I'm just trying to... Oh, right, so that seems to hold... This whole thing moves when it... So, I wonder what that plastic thing's got to do with it now. I've kind of dislodged it. I'll see if I can put it back into how I found it. I don't think I've broken anything yet. Well, regarding this bit anyway, I think I've broke the mechanism in this. Oh, shit, maybe. Hang on. I'll put the camera down. So I've got it back into the original condition, the way it was found. That's, you know, all I broke was the front cover just to get in there. But that's irrelevant here. What I want to know is how this works. So that's kind of like how it's going to go in. So I think when you close the door, you know what? I'm going to take this whole locket. I'm going to take this apart. Right, that's Torex. No, I bet that's the only tool that I've not got in the toolbox to get that out. But I'm going to take this off the door and reveal what's going on here with the, as regards the door mechanism. Test it. I don't have the blooming tools for it. I'm not going to be doing to the lock up to dig the tools on. It's going to get dark, and that's a blooming rain on it as well. Great, eh? I've tried a couple of Allen screws, it never worked. I tried to do it with a Phillips, it's not going to come off. So I don't know what to do yet. What I'm going to have to do is I'm just going to have to probably just call it a night. It's getting dark now. So I think, see if I could maybe, see I can't really break it there. The plastic on that's quite strong. So you can imagine how this is strong. This has got to be super strong. And I don't have the tools at the moment. I might do this for another video. I just can't be bothered tonight. That's the type of tool I need, and I don't have them. I know where they are, just buried in the locker, but I'm not doing that tonight. It's going to be arsed. For now, I'm just going to have to guess. I don't think there's a lot to see in there anyway. It's just a pivot and that holds your glass in. I'll maybe do this on another video. So, I don't know how that. I'm just trying to think now how it actually works. How the door interlock mechanism works on this. Any ideas? If you do, just stick them in the comments. Actually, this thing moves as well. I wonder about that. So, let's see. Look at the shape of the no, hang on a minute. I don't know, I'm just going to try and show you this. See, what I'll have to do is try and operate the handle at the same time to demonstrate how it works. That's the shape of the latch. So when you're moving the handle and you open the door on the washing machine, that's what you're doing. You're pulling back on the spring that's operating this latch. Now that latch must be like an anti-burst latch like that on a car, you know, safety. There'll be like, I guess there'll be like a double rocket or something on it. So it's, maybe I'll have to do that for another video. I just didn't have the time. What I'll do is I'll rip this open anyway, because no, I won't. No, I won't actually. I'll keep it in situ because demonstrate on another video. But anyway, that must move through. The electricity will go into here, and it will cause that metal thing to move, which will make this plastic bit move, which will somehow manage to prevent this lock from being allowed to open when you try and open it manually with your hand on the other side. That's really all I'm doing. I'm not quite sure exactly how it works, but that's the best I could do just now. So that'll do it then. What I'm going to do is now we're going to put these parts in a nice, neat, orderly fashion, and I'll take some photo stills for the photo slideshow at the end, and also for more records. So I shall get that done, and then once I've done that, I'm going to tidy all this up, call it a night of that. I don't suppose there'd be much to see in there anyway, in that door thing, so I could do that for that video. But first things first, let's get this in a full shot order. Before I do that, I'm just going to show where that door lock mechanism fits on the panel. There's these two screws there, and if I get the thing, that somehow kind of operates like that. So when this is fixed to the metal panel with the 2 screws, that's locking the door into lock. It's definitely that way, because the screw's coming from the front as well, by the way. So when that's locked to here, to the metal panel, once it's locked, does its thing, you can't open the door because this is locking this latch, but this is locked, screwed to the panel. So that's what's preventing. That's where this gets its muscle from. This is screwed to the metal panel. So when this does its thing, it locks this latch. Right? It's all locked together as a one then. So it fits sort of like that. Although this is plastic, it's quite strong as well. Ah, there's the sun coming out now. Well, the sun's set. It's not going to be long before it's dark, so I'm going to have to be quick now, but at least it's giving me some light for decent photo shots before I tidy this up. Put them in a sort of tidy order, tidy-ish anyway. I didn't show you the other side of this, did I? Can't remember if I did or not, but there it is anyway. In case I didn't show that earlier, I'm just... Flash DC module, so yeah, it's something to do with converting it AC to DC, so triac or something it's called. Right, so let's just go through them. I'll just do a wee summary now that I've got them in some sort of orderly fashion. Well, kind of. Right, okay, so starting with the soap dispenser drawer. This is the soap dispenser drawer here. Pre-wash powder goes in there, main wash powder goes in there, softener goes in there. Water comes in from the 2 hoses, solenoids, which are connected to the back of the washing machine. Fits in there. Comes under at mains water pressure. It's get energised from the brain of the circuits. The brain here tells them to energise, which causes the solenoid to open, which allows the water to flow through its natural mains water pressure. So it's just mains water pressure force. Come through these channels, as I explained earlier on, to get the softener to work. Both jets come on at the same time, causes the water to go through that centre channel. There's no any valves or flaps or anything that direct the water. It's just done by crashing the water together to form a centre water jet. Go through there to wash the softener down into the drum of the washing machine. This is the soap dispenser main housing. This is basically a demonstrator, just pressed down on that to release it. Right, so. Right, next. Move on to the main circuit board. So this is the brains of the whole machine. So where all your switches are, they correspond to the front panel. When you press the buttons, it just presses pegs on here. So just as I demonstrated earlier, which in turn presses these buttons, which are actually the main, that's the actual switch on the circuit board. Set your washing machine program on that with this, which turns this peg here that is connected to the other side of there, which goes in to the circuit board, which turns the actual electrical switch on the board, which is that blue thing here, as I demonstrated earlier. You've got your display, which shines through this plastic like window tinted plastic, protects the LCD screen and acts as a lens, I suppose. And that's just protective shrouding to protect the circuit board. Next, switch. This is what tells the brain that the water's reached the preset level. So when this makes a signal due to this diaphragm being pressed on, due to the air pressure in this hose, which will increase as the water increases in the drum. So as the water, basically the water in the drum will start to fill up. In doing so, it will cause this air in this pipe to, I would say, pressurise himself. That'd be my guess. So yeah, it's got to pressurise it, which will cause the diaphragm to move, which will act on this plunger and spring, which will cause a switch down there to basically make contact, which will cause a signal. You know, once you've got a circuit, you've got volts, you've got amps, you've got current, so you've got an electrical circuit made, which will that electrical circuit will be regarded as a signal, which will go to this brain. That will then say to the solenoid to close. It will shut the water off by cutting the power tip, and all the high voltage stuff will be controlled with these relays in there, I guess, because it's the actual muscles, the actuators. These will use high voltage, you know, mains voltage, well, certainly higher voltage, because it's got work to do. It's actually got mechanical movement to do. Whereas the microprocessor will just use very small voltages and small currents because it's just a microchip. Right, next, door lock. So I went through this earlier. It seems as though when this is energised, it causes this mechanical setup to move, which will prevent the door latch from opening somewhat. I'm not very clear on how it works, but that's just my understanding of how it works. So that's that. What else? I think that's pretty much it for now. In case you were wondering what that movement is, that's just a broken bit of plastic in there. So there's no any flaps, that's just a broken bit of plastic moving the bolt in there. Spotted another wee observation here as I was taking some still photos. There's this wee Phillips screw. Right, yeah, there's this wee Phillips screw. It looks as though it's got Loctite on it. I think that there is for calibrating the pressure sensor, so you could adjust how much water you want in the drum. So if you want more water, you would probably turn it one way perhaps. You want less water, turn it the opposite way. That'd be my guess. And that must adjust the amount of movement that this diaphragm is required to do in order to trigger the switch. So if you want more water, it might have to move a bit further, might need a bit more pressure. Perhaps, I don't know. So as the water level goes up, it'll go up in here, which the air pressure will start to pressurise, which will cause this diaphragm to work. No, I don't think it could be any other way. I don't think it works on a vacuum. Well, it's negative air pressure, positive air. It'll start to be positive pressure as the air pressure increases. So act on this diaphragm, rubber diaphragm, and that'll say, as I say, that'll be calibration screw, I reckon. And that red stuff's Loctite so that it doesn't move, because it's sensitive. Once it's set in the factory, they don't want this to be accidentally moved, because remember, the washing machine's got a lot of vibration. A lot of vibration in a washing machine, so things have got to be locked tight, and you know, it's got to be like rubber between that and metal panels, because there'll be a lot of vibration and it's got to soak up the vibrations, because if we don't, it would maybe start to work harden or you know, fatigue the plastic. It doesn't do the circuit boards any good, especially electronics. So all this stuff's got to be, bolts and screws have got to be serrated washers and stuff so they don't work loose. That's another method to stop screws and nuts coming loose in situations where there's lots of vibration, such as these serrated washers. So it's all there to stop things working loose. Yeah, so I'll just cut it and take some more photos. That's me finished taking my still photographs. I think I've covered everything for this episode. So can't think of anything else at the moment. It's getting cold, it's going to get dark soon, and I've got things to go on. So that's it for this episode. So maybe in the next episode I'll see if we get that door open. You know, the bit of us, you need to get a, what do you call it? Can't remember what they're called. Torx. I need to get a Torx to get into the back of the door. Okay, right, well, that's it then. So I'll just see you in the next episode. Right, see what else put on my channel, and I'll catch you later on. Okay, bye for now. See you later. Bye.